The distribution of a continuous variable is a very important descriptive statistic to report for it's a essential part of inferential statistics. The distribution of sample, for example, uh, will indicate whether certain types of inferential statistics could be carried out. So basically, later on, we talk about the parametric and non-parametric tests, and the distribution is actually one of the most important factors that contribute to the decision making of whether to use parametric or non-parametric methods. So there are various ways to detect the distribution or to describe the distribution pattern of a continuous variable. Here we use the one of the most straightforward way of detecting the distribution, that is to plot a histogram, which is basically a diagram that give you a very straightforward answer in terms of the shape of the distribution. So before we work on data, I just quickly show you some examples of a distribution. So here we have, well, this is a variable called total perceived stress. Of course, it all depends on the sample. So the same variable perceived stress could form a really nice um, normal distribution or not, depends on the sample. So here, what we can see for this total perceived stress in terms of distribution, so we have the actually value on the x-axis and we have the frequency on the y-axis. And this shape, we call it a bell shape. So this bell shape distribution is actually a, a distribution that could indicate a good parametric statistic method, which is a normal distribution, bell-shaped distribution, a normal distribution. Where this total optimism, we can see that it's not a perfect normal distribution at all, because it's actually missing some tails on the right-hand side, and it has some gaps here as well. So we could call this a normal distribution, but this one, it's not a normal distribution, or at least it's a biased distribution that might be able to be correct to be similar to normal distribution, but without any correction, it's not a normal distribution. Okay, so with our data set, I'm still using the data set we used previously, but because the observation is too small, we've only got 30 observations. The distribution will look a bit, sparse in a way. So the best thing to do is to actually download a longer data set so we could use for this kind of work. Let me just quickly show you where to download that longer data set. So this is the complete data set. So previously we've downloaded something called a Survey 5ED short. But by this link here, you could actually download the whole Survey 5ED dataset, which include many things that are similar to our dataset, like self-esteem, life satisfaction, age, education, but it also has many, many more variables. But most importantly, this new dataset has a much, much longer observation. Instead of 30, it has a few hundred, I believe, give us a more flexibility or accuracy to estimate the distribution. So once you've downloaded, I have it here with me. So it's this one, 35ED. I just open it, and you can see that instantly. There's way more observations. We got 439 actually. If it's Excel, it's 438, but because it starts from row 1 in this case, so it's actually 480. Is it 480? Sorry, 439, not 438. So we need to find some continuous variables to carry out the histogram check. Histogram is a distribution check, it's only for continuous variables. So I don't mind to check on the age because that's something we've got as well in our original data set. And let me just go back to here. So I'll check the distribution of age. Essentially, that is drawing a histogram of age. How to do that? We go to the tabs that is called graphs. You could actually build your chart, but in this case, we use the menu that's already made. Go to the bottom of the legacy dialogues. Go to legacy dialogues and go to the bottom of the submenu and click on histogram. The only thing you need to do is really just move age to the first empty space on the right hand side, and you don't need to change anything else. Just click OK, then a distribution, a histogram will be generated. So by looking at the histogram of age, you could see that it's clearly missing the left-hand side tail. By tail, I mean these slopes that reduce gradually. So there's a missing slope here. So it's not a normal distribution. I try another one. Maybe we've got a luck of another one. So let's see life satisfaction. So that's optimism. I think life satisfaction is this one. Okay, no problem. So we'll just quickly test the distribution of life satisfaction. Just move age back. Total life satisfaction. No problem. Okay, so in the uh, report window, we could see that, okay, well, you can see that it's still missing on the right hand side in terms of the tail, but overall, it's still not a perfect normal distribution, I'd say. Although you might argue that it has some elements of normal distribution. Well, you could actually use some method to correct for the bias distribution to make it more like a normal distribution, but it's beyond the curriculum of this module.